So one way that, like I said, today's all about classifying igneous rocks. So we already just talked about classifying based on the magma source. But we can also classify based on the grain sizes. And so when we do that, basically we can have a lot of different grain sizes. Are they fine grained? Right, I guess above fine grain, we probably should put glassy. So again, if it's a glass, there are no minerals that are forming on its surface. There's none. That's what needs to be a glass. So we have no mineral grains. If it's fine grained, we have very small mineral grains. And then we go to coarse grain or large grains. An example of that would be granite. And then we can also have very coarse, and these are called pegmatites. And then guys, again, texture, it's not really something we need to be spending a lot of time on. But it's definitely kind of worth our time a little bit to discuss what it really means. And again, all the textures are really kind of the way that it feels, right? So I mean, you can feel the coarse grains when you pick up a piece of granite. You can see them, you can feel them. Again, glassy, typically going to be that beautiful, smooth color to it. So one of the last things I want to talk about today is the uses of igneous rocks. And a lot of our igneous rocks are going to be in the form of ores. So we get a lot of our ores. So what is an ore deposit? An O-R-E. What is an ore deposit? What does that mean to you? Alyssa?
Where you find a lot of it?
Yeah, it's just basically we have a lot of rock that has a particular mineral that we want. Okay, so it's just a large deposit or a large area. A large deposit of rock containing valuable substances. An example of that, so I showed you guys yesterday, this is iron ore. Yeah. So what this literally is from the side of a rock face, huge cliff, about 200 feet tall. And then literally use dynamite, blow the face apart, you get these little chunks. And in this, somewhere, is iron bonded into other things. So this is an example of an igneous rock. We call it an ore because it has valuable substances. That's what makes it an ore. Now, sometimes those ores can come in the form of veins, right? This is when we think about copper mining and gold mining and silver mining. Early in the stages here in the United States, we found a lot of those substances in veins. And what that looks like is exactly what this image is right here. You have this parent rock, and then you have the vein that runs through the rock. And what that is And how that happens is you have this super hot water that basically finds its way through cracks in the rock. And as it goes in there, that super hot water leaches out some of those compounds out of the rock. And it keeps it in a dissolved state. So I want you guys to kind of envision this. This little yellow section, imagine that being just complete water. Very, very hot water. What do you think is heating the water? Magma. So it's typically going to be around a volcanic area. So you have all this water being superheated. And remember, we talked about this earlier. The hotter the water, the more it can dissolve. So you have this really hot water dissolving away these minerals. And then if the magma chamber shifts and moves away, what happens to that water? What does the water start to do? If it loses its heat source, what happens to the water? It starts to cool. And then as it cools, all those ions that were kept in solution, what do they start to do? They start to crystallize. And that's basically how we get a lot of our gold veins. So that's one way that we can have ores deposited. Another way that's called a pegmatite. This is where we get basically deposited all together as one super clump of material. That's basically what a pegmatite is. It's just a super clump of material. And then the last one is called a kimberlite. Where have you guys seen kimberlites before?
National Geographic.
Okay, explain.
I see you cover and there's a big hole and this guy's jumping in.
That's a sinkhole. Well,
That's
not
what
kimberlite.
he's doing.
Well, they're easy to get confused. The difference here is the kimberlite comes from Kimberley, South Africa. What is South Africa known for?
Being very wealthy.
Why?
Uh,
What are they rich from?
gold.
Gold, and what other important concept? Diamonds. Okay. How many of you guys have heard of De Beers? Diamond company, our world chain of diamond company, De Beers. Okay. Well, it's a really sad story, actually. I'm not sure if you guys know this, but here's a little bit of the history of South Africa. It was a Dutch colony, and so basically a lot of the Dutch were leaving places like the Netherlands and but anyway, so they were leaving, they were settling in other places in the world, and so one of the major places the Dutch settled was South Africa. So when you hear the name De Beers, pretty much Dutch.
That's a sad story.
No. De Beers. Yeah, I spelled that right. But anyways, what's interesting about this is the Beard family is actually a farming family who happened upon one of these kimberlites near Kimberley, South Africa. And all the kimberlite is this cone, this inverted cone, where you have igneous rock that is deposited all along the sides of this inverted cone. As we see here, some of that has been filled in with water, but it's all this wonderfully thick magmatic rock that's been deposited. What happens is as that lava is being shot out, it gets really, really compressed. And so we start to find are diamonds all up and down the sides of these kimberlites. So here's the sad story. What happened is a company, a mining company, came in and bought out the De Beers farm early on, like we're talking like late 1800s, and they're still mining the same area today. And they kept the De Beers name. So, kind of think about that one for a minute.
Make their family look good.
So, definitely made their profit from buying the property. So, a little bit there. All right, now your homework for tonight. Luckily, our copier is broken. So I did not get a chance to copy all the homework.
Oh, don't.
But don't worry.
I was
No.
already worried.
I have a PDF file of it. And I will make sure that it is on my big campus here in just a few minutes. So if you guys will please, if you're already on my big campus, you need to log into Rocks and Minerals and go to Classifying Igneous Rocks.